Greetings, ladies and gentlemen. Welcome to the Classical Academy Podcast, your friendly guide to the world of classical Christian education. I'm your host, Dr. Mark Phillips. Listen, before we get started, if you're enjoying our podcast, please subscribe and give us a review and share the podcast with friends, with family, with anyone who could use a friendly guide to the world of classical Christian education. Maybe you've been talking to people about considering going to a classical Christian school. This podcast is a great insight for them. I used to live in Colorado, and I did some cliff climbing at the foothills of Pikes Peak, and occasionally I would spend the night there, foolishly exposing myself to bears and mountain lions. But I remember the night sky, and I hope everyone's had the experience of going out into the country, away from the light pollution of the city or even a large town, and staring into the night sky. And it begs some questions. When we stare out at the night sky, are we looking at just a swirling mass of chaos, random events, random nuclear fusion on the stars? Or is it a divine dance of beauty, harmony, and order with a divine mind behind it? And does being a Christian help us, or does it hinder us in our quest to understand these questions, to understand the very universe in which we find ourselves and our place in it? Well, my guest today is going to help us answer these questions. It's Eric Margrave. He teaches logic level earth science as well as a couple of courses to the seniors here, helping them on their way out into that world out there. He teaches AP environmental science to them as well as apologetics. Interesting thing about Eric, like my daughter, he has made multiple mission trips to Uganda, and in fact, on one occasion, he didn't quite make it back. Eric, welcome to the show. It's great to have you.
It's good to be here.
So why don't you tell us about this trepid journey home from Uganda that happened once? What was that all about?
Well, on one of my trips leading high school students, we had a 2-day layover in Dubai. And after everything went according to plan in Uganda, some wonderful time with door-to-door evangelism, preaching the gospel at schools. Almost everything went wrong in Dubai. That could go wrong. 3 of the young ladies in our traveling party lost their passports with a taxi cab mix-up. And a long night ensued as my co-leader, Greg, tried to track down the passports, and I tried to stay with the rest of the team and have an orderly dinner and try to keep them calm. And in the meantime, realizing that there's no embassy in Dubai, and we have to work with the consulate, and since they are minors, they might have to be signed over to my custody for the time being. And by God's grace, miraculously, even though the passports were lost about 12 hours before our flight, we found them 3 hours before our flight.
Amazing.
An honest cab driver turned them in to the local police station, and we were able to track them down, and it was a great relief. We made it home.
One of the many stories of mission trip miracles. Good. Well, obviously, we knew you made it. I was wondering about the girls as the story went on. I'm glad they did too. So when one of the things about earth science, at logic level especially, we study astronomy. And so kind of an overall question, why do we study astronomy in classical education?
Well, astronomy has long been considered part of the quadrivium, one of the 7 liberal arts, or as I try to explain it to the students, just the arts that set us free. That set us free as free beings to think about what we have time to think about. And Aristotle said, all wisdom begins in wonder. And what has made humans wonder more than the stars and the heavens? And it is the oldest science. It's been practiced for well over 5,500 years, and it has had a tremendous influence on mathematics and the scientific revolution.
And of course, it was one of the early phases of the scientific revolution, Christians being those first astronomers. And everyone thinks of Copernicus, but really, Johannes Kepler was really the strong force of moving us into modern astronomy. So who was he?
Well, for those not familiar with Kepler, he was a contemporary of Galileo, and they're coming immediately after the time of Copernicus. Copernicus publishes his book the same year that he dies in 1543. And Kepler is living in Germany. At that time, it was not Germany, it was considered the Holy Roman Empire.
Sure.
And Galileo's living in Italy. And they're both reading Copernicus, and they are both thinking about the novel concept, which was somewhat novel at the time, of how do I prove this to be true? His observations, his geometric calculations seem to be consistent with what I see, but how can I prove this to be true? And that's part of what makes Kepler and Galileo such an influential force going forward. They were not simply looking at the planets, the motions, as making predictions, as the Ptolemaic system was, but they actually looked at it as a series of real objects that were moving and that they could discern because it's based on an orderly creation.
So people hear the Ptolemaic system and the Aristotelian system. What are those, so that the listeners can understand when you say they were moving away from the Ptolemaic system? What was that?
Well, Ptolemy is considered one of the foremost ancient astronomers. The Library of Alexandria burns, and really not a lot of the ancient works survive. But Ptolemy puts together what he can in his work called the Almagest. And the Almagest is called the greatest, and it's sort of his collection of the ancient works of astronomy and science. But Ptolemy very much makes it clear in his writing that he's not showing the motion of geocentrism, the Earth at the center and the planets going around and the sun going around as well. He's not showing it necessarily as a picture of reality, but he's showing it as what works to make predictions. Because they're interested in the signs and the seasons in ancient astronomy. Classical astronomy is about making those predictions for what's coming next.
And a lot of his predictions, even with an Earth-centered system, were actually quite accurate.
His predictions were amazingly accurate. One example is, I do the little map on the board for the students. Mars has a retrograde motion, which means when you're watching Mars from Earth's perspective, it's one of the easiest planets to see in the night sky. It's somewhat low to the horizon. It's a reddish orange. And it has a period in its orbit where it appears to move backwards, retrograde. And then it continues back forward on its normal revolution.
Fascinating.
Well, Ptolemy explained this with circles within circles. He called it epicycles.
Yes.
And his predictions were just amazingly accurate, but they were based on a false premise.
And so along comes Copernicus, like you said, not a lot of empirical data to back up his ideas. Kepler, as you said, now struggled. How can I prove this? It does make sense. So how did astronomy change when Kepler came along?
Okay, so just to be clear, Copernicus is considered the founder of heliocentrism, the sun-centered solar system.
Right.
And you were right to note that Copernicus doesn't really base this on a lot of observations. This is pre-telescope. So telescopes invented around 1608, 1609. Copernicus dies in 1543, but Kepler and Galileo are very keen observers of the night sky, very keen systematic observers that take detailed notes in their journals. And part of what they're looking for is verification, natural verification of what seems to be a system that makes sense that Copernicus writes about, but hasn't really been validated by observational data.
And so now what kind of orbits, shapes of orbits did Ptolemy have? Was it the same with Copernicus? Did Kepler change that? What happened there?
This is a good question because in the ancient Greek model, the circle was considered a perfect shape.
Perfect form.
Perfect form, the shape of perfection that sort of represented the divines. So Ptolemy's system is based on perfect circle upon perfect circle, concentric circles. Copernicus does not alter this system entirely. He basically shifts the center of the solar system from the Earth to the sun, but he continues the concentric circle idea. And this was something that Kepler really struggled with throughout his observations for many years, was thinking the circle makes sense based on tradition, the circle makes sense based on what we've been taught, but is the circle really what matches observations? And that was really his breakthrough once he realized the circles are not what we see in the orbit. It's actually elliptical.
And I think we see the Christian influence here, that the Greeks said, whoever the creator happens to be must work within these perfect forms. And the Christians came along and said, well, wait a minute. Can't God do it however he wants to? Why don't we just observe and see? And so his observations, what you're saying is the idea, seems like elliptical is what's happening here. It looks like that's how God did it, rather than forcing God into this idea of just a circle.
Yeah, with Kepler, we're really seeing a shift from sort of the whim of the gods approach to science, or the way it has to be, to this observational verification order of science where we can look at nature and see an orderly design because we know we have an orderly designing creator. And Kepler was not slave to the circle. He can look at the other possibilities. And that took many years for him to work through.
You bet.
And both pre-telescope and after the telescope was invented, Kepler was still making observations.
Now, another interesting thing, of course, astrology was also something that Kepler had to wrestle with in his time. So, of course, when we look at history sometimes, we just think, oh, these big jumps, almost a punctuated equilibrium of history. But this was very much a reality in his world. How did he deal with astrology?
It's a good question. I think part of Kepler's story that is endearing and such a compelling story is that Kepler struggled through much of his adult life to pay the bills. And he was working as a mathematician. He was working as a teacher. He was working, at one point he thought he would be a theologian, and then he thought, I can do theology through astronomy and math. And one of the ways he was trying to make ends meet was he would basically be the district astrologer.
Wow.
And he was kind of like this consultant that you think of like an almanac, like Poor Richard's Almanac, where they would consult him and ask about when should we get married? When should we do this? When will the crops yield? And Kepler, the more he studied the planets and the stars, the more he was beginning to realize that these types of motions have no effect on human behavior. And these things are based in superstition, and he wanted to no longer be a part of that as he was doing that job through the years. And he eventually stopped giving the personal advice that came with astrology.
So as a Christian and as a scientist, he started realizing, I don't see the empirical data to support the way we've been treating astrology, and that was probably the beginning of the end of it as considered among the sciences. Is that right?
Correct. Yeah, his influence was significant throughout Europe, that once his so-called almanacs were published throughout, that people saw that this was the new standard, because he was becoming a known professor as he was publishing more of his findings, and people were beginning to realize these aspects of astrology where we think it affects human behavior, this is not really science at all.
A little bit off topic, but why have we seen in the last couple of generations such a resurgence in the interest of astrology if it's been so disregarded as scientific now? Any ideas?
I think it's a search for meaning and purpose in young people's lives. We're seeing so much in our culture post-Christian and less associating meaning with God's word and with God's calling for our life, and more search for meaning out there. There's a justification for certain behaviors when we look at our astrological signs that, I can't help it. I'm a Gemini. I have to do this.
Right.
I think there's certain aspects of that. And I think there's also a certain sense of like hidden knowledge.
The arcane.
That has an appeal to so many, no matter what the generation, not just young people, where you're like, I know astrology. I know why you're acting like that, because you're a Pisces.
Yes, right. And of course, as scientists, we're telling people, yes, there is a lot of unseen knowledge. Become a scientist. Try to discover it. Yeah.
Exactly.
So we mentioned Kepler's faith earlier, and I know here at Trinity, we teach the students how modern science has its roots in the Christian faith, how they broke away from the Aristotelian thought of forcing God to create a certain way. Hey, why don't we see how he did it? How did Kepler's Christian faith play into the activities and works of his life?
Kepler's faith definitely shaped everything he did throughout his adult life. One of the things we memorize for 7th grade in science is a quote from Kepler when thinking about why do we do astronomy. He says, quote, to discover the rational order and harmony which has been imposed on it by God and which he has revealed to us. So there's a couple of key things about that quote that I try to reiterate for the students. It's not only that God creates order, that we know from an orderly God, from an orderly revealed word and orderly revealed nature, but also he reveals it to us. As his image bearers, he wants us to discover that nature is intelligible. It's not just a complicated, chaotic mess of swirls and nebula. It is intelligible. It's something that we can discern with the scientific method, with wonder and work, and eventually, hopefully, that wonder and work will lead us to worship.
Sure, which is what astounded Einstein. He said the most unintelligible thing about the universe is that it is intelligible. He found it fascinating that we could actually study it and make meaning of what we studied. I know that quote, didn't Kepler add that God uses the language of mathematics, which is this order and harmony. And
exactly.
So it's a beautiful thing. I think it's really important for Christians to understand that science and Christianity are not only not at war, but they are totally interdependent upon one another. And modern science is founded in that place, as demonstrated by Kepler's quote.
Correct. Yeah. And I think one of the things that, we think about why we do it at a place like Trinity, at a classical Christian school, we're trying to sort of reestablish that normal intuition that most people have, that this thing looks designed.
Yeah.
I think it's designed. And in some modern universities and some modern schools, we're being made to sound foolish when we make such deductions.
Sure.
But design is an assumption. It's a working way of doing science, but it also reveals more, because Kepler's not merely saying God did this. Kepler is saying God did this, and because he did this, I can discern more detailed predictive elements of this.
Sure.
Whether that's the orbit of the planets or predicting different motions even of asteroids or things like that.
Sure. Yeah. And God's given us these hints in the sky. Of the nearly 200 moons in our solar system, only ours gives a perfect eclipse where you can actually study the corona of the stars. Where we're located in the galaxy is a place free of deadly radioactive dust, but it's also free of dust that would block our vision to the rest of the universe. The best place to see the universe is where we are, where there are observers. These hints are they're no-brainers to those who believe and those who accept, as you said, the common sense observation that if something looks designed, it is.
Yeah, and we want to reiterate that to the students, and we want them as a firm foundation to fall back on when life is going to become difficult. They're going to have seasons where they question their faith. We want them to fall back on the facts of what we know. What we know is that we were designed, we were created in God's image. The universe cries out his glory, that it is made plainly obvious, as Romans 1 says.
Yes.
And we want students to see that clearly.
Right, indeed. And everyone read the first 2 verses of Psalm 19 after you hear this podcast, right? That the heavens declare the glory of God, that it is God's second book. His primary book is the Bible, but nature's his second book, and it speaks to us. It's shouting to us, and that's beautiful. So that brings us now into classical Christian education. How do we study astronomy in a classical Christian education setting?
Well, I think I want to preface that with we do it imperfectly, because the ideal in studying astronomy, whether it's classical astronomy or modern astronomy, would be at nighttime with the telescope,
Sure.
making observations, talking about things like that. So we definitely have a ways to go, and I think there are ways that we can improve what we do. But we're trying to instill that wonder and that work in astronomy, but also the worship that comes from that. So whether it's memorizing Psalm 19 you mentioned, if there are any 7th grade parents listening, your student should have all of Psalm 19 memorized at this point in the school year. I want them to see all of it. The psalmist is actually connecting God's general revelation in the first 6 verses to his special revelation in the next 5 verses, to a prayer for petition and help in the last 3 verses. So I would encourage parents, ask your students, see if they have it memorized still. They'll have one more chance coming up on the final exam.
Yeah, very good.
So
Wouldn't hurt you to memorize it with them, parents.
Absolutely. So to answer your question, we do astronomy in a lot of different ways, whether it's through creative projects, like we will actually model Kepler's elliptical orbits of the planets. We'll make little paper models, and I'm try to help them see that in some ways it's counterintuitive, because a circle has one focus in the center, that gravitational well, which would make sense in a Copernican model. but an ellipse has two foci.
Yes.
So we build on previous knowledge, working on gravity and inertia, and we talk about how that other foci is not an actual object in space.
Mm-hmm.
It's just due to the phenomena of the inertia of these objects.
Right.
And so we go out and we map all of those planets, going all the way out to Pluto for a comparison, and getting some of the dwarf planets in their highly eccentric orbit, which is a term for kind of like a squished circle.
Yeah.
And we help students to see that. Students also create Constellation Shoebox, where they do a little research on the constellations, the history behind the constellation, how it got its name, and the mythology behind that. And they create posters or where they learn about the mythology as well. So I try to bring in elements in class where it's like, I know we're not doing all the classical elements of astronomy, but we are doing elements that can kind of make it alive for them. And we're also using a wonderful book that I would highly recommend by Jay Ryan's Classical Astronomy called Signs and Seasons.
Signs and Seasons.
Signs and Seasons. It was originally intended for a homeschool audience, and I just use a few chapters. Excellent book. And we use a few of that, and we read in class, and we talk about these things, and we try to simply even look at images of space and like, how does this evoke wonder in you? What do you see that's orderly? What do you see that might be perceived as chaotic? And what do we know about that? And they've learned about the nebulae and what all the colors of the nebulae represent.
Wow.
So there's a lot of different ways we'll try to cover that, all of it imperfectly, realizing we're not doing classical astronomy perfectly.
Sure.
But then again, we're not doing anything here perfectly.
So as the students are doing all these activities and imperfectly studying, how do you see them being shaped by the way we study astronomy here?
Well, I think there's a lot of power in that assumption of order that we touched on it earlier in the conversation, that I think one of the criticisms of the design inference, as some Christians have called it, some of the criticisms is that it's a God of the gaps type of reasoning. But what I try to help students see is that a presumption of order is not a God of the gaps, that we are actually seeing that where does order usually come from? Order usually comes from an agent, an intelligent agent that designs things, that wants you to find them, like a person setting up a scavenger hunt. They have set it up in an orderly way where they want you to find it, and if you reach a clue where you can't find the next clue, either you're missing something or they did something wrong. But there's order, and that presumption of order, I think, has a big effect on students, whether it's, trying to figure out the next question on a test, whether it's trying to think about what some of the mysterious things in space that we touch on, like dark matter, dark energy, black holes. There's still a presumption of order because we know ultimately where all of this came from. So I think it gives students a peace of mind. It gives students a secure grounding in their studies, that we know that even though we don't have all the answers are intelligible and we will get to them.
Well, sure. That's fantastic. Well, bring up Einstein again. I mean, when he was working his space-time theorems and relativity, he was not in any way saying this means there's not order. He got angry with those who tried to take his theorems and his idea of relativity and turn it into some kind of chaos. And he said, that's not what I mean at all. We're just merely moving from one constant to another. And he still believed in constants, still believed in order. And I think it's great how you're taking that in astronomy and letting the students realize when you make that assumption, you're going to expect certain observations, and those are the observations that you make.
Exactly. And even for our older students, as we push them to understand elements of like quantum physics,
right?
There are some skeptics that will say quantum physics is an evidence of chaos. But no, actually, there's probabilities that are involved in quantum physics that show signs of order. That even though we cannot make exact predictions, we have probabilities that can make somewhat accurate predictions over time.
Yeah, exactly.
So all of these things point to a creator.
Yeah, we still mathematize them. Well, you can't mathematize them if it's meaningless.
Exactly.
And all the way back to Kepler again, God speaks in the language of mathematics. So if I'm a parent, not only of a logic student, but really any student who has been through the astronomy studies in a classical Christian education, what might be some interesting questions I should ask them?
I would love for you to ask them, what sort of signs of order and harmony do you see, do your students see in the planets, even in something like the heliocentric model progressing out of the geocentric model, out of the ancient Greek sort of understanding of the universe. What are the signs of order that you see? What are the signs of progress that you see? And what are the assumptions of the Christian worldview that help us to learn more about reality? And what are the working assumptions of the atheistic worldview that might not lead to a better picture of reality? That I want students to kind of see all of those issues together, that it's not just about understanding, here's the order of the planets and here's their eccentricity, but I want them to understand the underlying worldview that led to those discoveries.
That's fantastic. So parents, that's where you want to go. You want to ask where they see order in this, and ask yourself that. What's the name of that book again? I think everybody should be grabbing
Signs
that.
and Seasons by J. Ryan. Excellent short book.
Yeah. Okay, gang. That's something that sounds like it's worth reading. That'll give you some more good questions to ask your students. This has been fascinating. It's been very encouraging, Eric. Thank you so much.
Thank you for having me.
joining us. And folks, I hope you've been encouraged to see how studying the sciences in the classical Christian way and studying astronomy in a classical Christian way really does point to this orderly, divine, loving mind, the God of the Bible. So thank you so much for joining us on this episode of the Classical Academy Podcast. It is presented by Trinity U, a service of Trinity Classical Academy right here in Santa Clarita, California. Our producer is Shay Ramquist. Stephen Petrie is our audio engineer and provides our original intro and outro music that you're hearing right now. So until next time, let's all continue to grow in wisdom, in virtue, and in the love of God. Till next time.